Hello, good morning, everyone. And our project is a joint effort with also Professor Jian from CEE and Professor Xiaoming Hu. And the goal here is try to do virtual sustainability lab, which is kind of a numerical modeling system, and deal with climate adaptation in megacities. And we try to utilize some existing expertise in our group, and starting from doing urban flood modeling and doing a prototype. So the main goal is that this lab is built for climate adaptation purposes, and with the initial targeting lab prototype, simulates, predicts, and weather scale, and also projects a climate change scale. The urban flood hazards in Metro Atlanta and Savannah. So we picked two major cities in Georgia. And the significance why we decided to do that is because climate change drives changes of urban hazards, including floods, heat waves. So the design of a very effective adaptation measures at megacities also demand accurate knowledge of these multiple components and multiple processes of both human and natural origins. So our lab will offer the climate mitigation and adaptation community a suite of data analytics and high-performance computing tools for exploring ideas in climate environment, energy, and sustainable development. So the method we adopted is basically we built a coupled hierarchical data simulation and a prediction system. And the system includes like several components. The first component is a data simulation component. Basically, it assimilates and take in real-time local weather and environmental data. And this includes both the ground-based observations and also the remote sensing data we collected through radar and satellite. And this will feed into mesoscale meteorological model that can run at a very fine resolution, and it can go up to like tens of 50 meters and up to typically it's run at like a half a kilometer range. And we have this high resolution mesoscale weather model, and also have a very complicated urban component. And the last component is a multi-scale flood model, which integrates drainage system, pipe system of a megacity. So that in order to deal with urban flooding. So we run this model, and we can do this real time and to forecast the flood risk. And we can also take coarse resolution climate model projections, try to drive the look at do many cases of simulations to see how the overall the risk at these cities have been changing, and both their locations and spatial, how their spatial structure has been changing. Now we have did some validations in the past couple of years, and try to validate this model first with a few flood cases from Savannah, and we actually writing a paper already on that, and also presented results at the last year's one of the conferences in our field. And the next step here is that we will do some further validation of the model and with more urban flood cases, and also try to construct a flood risk map for Savannah under the present and future climate scenarios. And furthermore, we are exploring some external opportunities, including the DOE, which focuses on the climate in the Southeast United States. Now, in terms of needs and computational resources, is always the number one thing we need, and to run these high-resolution models. And we also need to work with the city of Atlanta to obtain the data for the city drainage system, because this is very necessary in order to get this thing going. And we also want to engage more relevant stakeholders, and including like water resource managers and local risk managers, and for insurance and for city planning, and try to explore more applications of this system. Okay, that's it. Thank you.